Okay, example of a hypothesis test in a geometric distribution. This example is in your online textbook, just so you know. I've just popped it up here. I don't want to rewrite the book, so I'll go through this one. So a company claims 1 in 8 of their packets of crisps contains a prize ticket. Lee decides to test this claim. He buys a packet of crisps each day until he finds a prize. And he finds it on the 24th day. And we want to test whether there's any evidence to suggest the company is overstating the proportion of packets containing a prize. So X is geometrically distributed with the probability of success being an 8 if the company's claim is correct. And so similar to the hypothesis test you've done before, the null is that P equals an 8. And Lead thinks the company might be overstating their support. So their support? Overstating the number of packets with the price. So the alternative is that P is less than an 8. I would define P. I haven't double checked a mark scheme, but I know on all the other hypothesis tests they like you to define your parameter. So where P is the probability a packet of crisps contains a prize ticket. I know we don't like words much in maths. Well, some of you might. So, the first success was on the 24th day. So, if P is less than an 8, that means that your first success is going to come later on. It's going to take you longer to get a success. And so rather than finding the probability X is less than or equal to 24, so if you're just matching signs, it's not going to work. You actually want to find the probability that X is greater than or equal to 24. So you're going into the right hand tail of the distribution, because if P is less than an 8, it's going to, on average, it's going to take you longer each time to get a success and win a prize. Then, using the probability theory from last lesson, if X is greater than or equal to 24, that's the same as saying that X is more than 23. So you won't have got a success on the first 23 trials. And you can't rely on your calculator for this. So 7/8 to the power 23, which is 0.0464. That is less than 5%. So that's too unlikely to have happened by chance that you get a result as extreme as 24 or more extreme. And so we're going to reject the null and accept the alternative. And then you need a conclusion in words. So there is evidence to suggest, or there is sufficient evidence to suggest. The company, so just pull it out of here, is overstating the proportion of packets containing a prize. just feels like unnecessary words. Once you've written that, then you have to write that as well. It just gets a bit annoying. We're not linguists, sorry, I'm not. So you're basically saying this is too unlikely to happen by chance. The probability you have to open 24 or more packets before you get a prize, that's just too unlikely. So we're rejecting the null. It's less than the significance level. We're rejecting the null and accepting the alternative, that P is less than an 8.